So this week, we're going to be taking a look at two different laws. Okay, one's called the law of sines, the other formula is called the law of cosines. And the goal for pretty much every problem this week is going to be find how long all the sides are in a triangle and how big all the angles are. Now, we've already done that before, finding sides and angles. But when we did it before, does anyone remember what kind of triangle we always worked with? Yeah?
A right triangle?
Right. When we did finding the sides and angles before, we always worked with a right triangle. When you're working with a right triangle, it allows you to use a couple things. Pythagorean theorem, that is something you can use. And you've got the opposite, adjacent, and hypotenuse stuff, right? Socotello. If you don't have a 90-degree angle, then you do not have a hypotenuse. No hypotenuse means no Pythagorean theorem. Can't use that. Okay. Also, if there's no hypotenuse, then there's no opposite over hypotenuse, adjacent over hypotenuse, none of that either. So we're going to look at what we can use in place of that. All right, so first of all, a triangle that doesn't have a 90-degree angle, it's called an oblique triangle. And there's really two main categories. We're not drawing anything to scale, so it's not overly important how we, like the two names of them. But one example of a triangle that doesn't have a 90 is an acute triangle. Okay, would look something like that. There's no 90. And another example would be an obtuse triangle, where you've got one angle bigger than 90. Could you have two angles bigger than 90? Not in a triangle, no. Because what do all the angles add up to?
180.
180. So if you had two bigger than 90, well, now you're looking at a four-sided shape or higher. Okay, you can't do it with a three-sided shape. Now, everything we're learning about these kind of triangles, you can go back and use it on right triangles. So it does work. The reason I didn't teach you how to do right triangles the way I'm going to show you this week is because with right triangles, we have something a little simpler. Okay? Pythagorean theorem is a little bit simpler than what we're going to learn this week. All right? So if we can use something that's easier, that's why we do right triangles that way. All right, so we need to set up a diagram. We're going to use the same diagram for every problem. What do we normally call the sides when we don't know them in a triangle? We use certain labels for them, letters. What are they? Yeah, we normally call them A, B, and C. And then what kind of letters do I always use for angles? What kind of letter?
Isn't it theta?
Well, we can use theta for an angle. Yeah, what kind of letter is that?
Greek.
Greek. So we usually use Greek letters for angles. When we have a triangle, what do we always call the one across from A? That one usually has a certain name. Alpha, yep. How about the one across from B?
Beta.
Beta. And then the one across from C was always the right angle. So we never had to give it a name. Well, this week it's not the right angle, so we do have to give it a name. And that name is gamma. So here's going to be our new diagram. Still has A, B, and C for the three sides. We still have alpha across from A, beta across from B, and this third angle is gamma, G-A-M-M-A. So gamma is across from C. There's no definite like A is the biggest or B or C are the biggest. Any side could be the biggest here. Okay, so it's not always going to be drawn to scale. I generally draw all my problems like that. What's important is that you always make sure A is across from alpha, B from beta, and C from gamma. Other than that, it doesn't have to be drawn to scale. All right, so there's different kinds of triangles that we could have to solve. And it all depends on what they give you to start with. Okay? Are they giving you some sides? Are they giving you angles? Do they give you some of both? Well, that's going to control whether we use law of sines or we use law of cosines. So we're going to go through the types of problems that use law of sines today. So in order to describe what kind of triangle we have, we're going to use 3 letters. And the 3 letters are merely to describe what pieces of information they gave us and the placement. Okay, where is the information? So the first 2 types of triangles we can solve with this law are angle, side angle, and side angle, angle. Okay, and you might say, what's the difference? In both cases, you have 2 angles and you have a 3rd side. Well, the difference is the 3rd side between the 2 angles they give you, like the one on the left? Okay. Between basically means it like connects the angles. It's between them. Or is the 3rd side they give you the side not between the 2 angles? Okay. The one between the 2 angles is on the bottom, on the right side. I did not give you the bottom side. Okay, so basically, no matter what, whenever you have 2 angles and 1 side, you use the law of sines to solve it. And you can write the abbreviation backwards. Well, the first one is the same, ASA. But if you also write AAS for that one, that's fine. It's the same thing. Okay, so those are both problems you use law of sines for. And so is this one. Okay, this one is a little bit different. Okay, this one they're giving you 2 sides and an angle. And it's very important where that angle is. If the angle is not between the 2 sides, the angle between the 2 sides would be this one up here. If I had given you that angle where the 2 sides meet, you wouldn't be able to solve it with this formula. Okay, can't do it. But if I give you 2 sides, and then the angle I give you is not between the 2 sides, so either this one, that's not between the 2 sides, or that one, then you can solve it with law of sines. Okay, and as far as the abbreviation, we'll stick with writing it in that order, SSA. It's not nice if you reverse that. So we'll leave it in that. All right. Any questions on the 3 types of problems that you can solve with law of sines? Well, not how to do them, just the information that you'd be given. So eventually, by the end of the week, we're going to have a table. One side of the table will have the 3 types for law of sines. And on the other side of the table, we'll have the 2 types for law of cosines. Okay, I'm not going to get into those till Wednesday. But one of them is side angle side. And the last one is side side side. Okay, so we won't get to those 2 till Wednesday. So we're going to focus on these 3 today, and this one we're going to focus on more tomorrow as well. Okay, there's something that can come up with this 3rd one that we have to deal with. Okay. And that's going to take us a little longer to go through. All right. So how do we use the law of sines? Well, first thing we're going to look at is what is the law of sines? Okay, so I'm going to show you how we get it. It's pretty easy to show you where it comes from. As long as you know how to work with right triangles, you can figure out what this law is. Once we have it, then we won't have to go through it again, and we're just going to use it. Okay? But we got to figure it out first. Okay, and to figure it out, I'm going to use this diagram. Okay, I've got a triangle. I didn't label all 3 sides because I'm not going to actually need the 3rd side to do what I'm about to do. But I've got A across from alpha, B across from beta, and then I drew in the height of the triangle. Now, does the triangle on the left and the triangle on the right look congruent? Do they look the same? No. Triangle on the right looks bigger to me, so they're not supposed to look the same. Okay, they're 2 different triangles. Right, and because that's the height, we can call it h. Again, now we could confuse that with hypotenuse, but it's height. So we'll just use h. All right, so what we're going to do first, we're going to look at the left-hand side of that diagram. Okay, we're not even going to look at the right side. Let's cover up the right side and just leave that. Okay, remember, if that's a 90, well, that's a 90 as well. Bless you. All right, so I've got two right triangles. Okay, I'm looking at the one on the left. First thing I want to do is focus on those three pieces of information. From this angle, what position is side H? Is it opposite, adjacent, or hypotenuse? This is opposite. So side H is opposite. And what about side B? Adjacent or hypotenuse? That's hypotenuse. Okay. So what I want to do now is come up with a trig function that involves those three pieces of information. Because that's opposite and that's hypotenuse, there's only one trig function we use that has those two in it. Does anyone remember, is that sine, cosine, or tangent? Which one?
Sine.
Yep, that's sine. So we're going to write down the sine of my angle, which in this case is alpha, equals, and sine is opposite over hypotenuse. So that's H is opposite, hypotenuse is B. What I want to do now is get H alone. So I want to put the B on the other side. Okay, so I'm basically calculating a formula for how tall the triangle is. How would we get the H alone? Yep, we'd multiply both sides by B and by B. So there's your formula for H. It's B sine alpha. And that will give you the height of the triangle. And I'm going to call that box 1. Any question how we got that formula in box 1? Because we're going to do the same thing again, but we're going to do it with the right side now. Okay, so for now, we'll come back to the left side in a minute. Let's use the right side. So this time, I'm going to focus on H, beta, and A. Okay, so now, if you were standing at beta, what position is side H this time from beta? Still opposite, yep. And what position is side A? Adjacent or hypotenuse? That's hypotenuse because it's across from the 90. Okay. I want to do the same thing I just did. I want to come up with a formula that involves beta, H, and A. What trig function would we use this time? Which one? Yeah, we'd use sine again. What's my angle? Beta. And what would go on the other side? H over A, opposite over hypotenuse. Now I want to do the same thing I just did. I want to find a formula for the height. Okay. How would we get the H by itself in that equation? Multiply both sides by A. Yep. So times A, that's gone, times A. And there is another formula to find the height of the triangle. A sine beta. And I'm going to call that box 2. So now, box 1 gives me a formula for the height of the triangle. Box 2 also gives me a formula for the height of the triangle. So what does that tell me about box 1 and box 2? They're the same. Right? box 1 is equal to box 2 because they both calculate exactly the same thing. They're just different ways of doing it. So let's write down that box 1 equals box 2. And now fill them in. So box 1 is b sine alpha. Box 2 is a sine beta. And once we rearrange that a little bit and put something on the other side, that's going to be our law of sines. The way they usually write the law of sines is they put the a over on the same side with the alpha, and they put the b over on the same side with the beta. How would we put the a on the left side? Move it from the right over to the left. Yeah, we divide. What would you divide by? A. So that's going to move the a over to the left. And now, how would you put the b over on the right? Divide by b. So basically, we're going to divide each side by a times b. B in the top, b in the bottom, that's gone. A in the top, a in the bottom, that's gone. So now you're left with sine of alpha over a equals sine beta over b. You are left with, I guess I had it down here. You're left with that. Sine of alpha over a equals sine of beta over b. And there is one more fraction. Okay, we could prove this last fraction by going through the same thing we just did and draw the height from a different side. Or if we recognize the pattern, which hopefully I think you might, we can probably take an educated guess what that last fraction would be. Yep.
Was it sine gamma over c?
Sine gamma over c. Yep. So that is the law of sines. We proved where the first two parts come from, and it all comes from just taking a triangle and splitting it into two right triangles. That's all that this law really does. But now that we have that law, we're not going to go through all these steps in the middle again. This law is going to save us a lot of time. Okay, when you use the law of sines, you never use all three fractions at the same time. You're either going to use the first two parts, the last two parts, or the first part with the last part. Okay, but you can pick any two parts that you want to use, and your problem is always going to look something like this. You're going to have a fraction on the left and a fraction on the right. There's 4 spots. Out of those 4 spots that you need to fill in, 3 of them will be given to you. 1 of them will not. So if you were doing a problem like this in Algebra 1 without trig, it might look something like this. Ours is going to have sine in it somewhere, but that's basically what you're solving, something like that. Does anybody remember how you solve something like that? Yeah?
Multiply both sides by the reciprocal, right, of x over 4.
Okay, so you could, you could multiply each side by 4. Yep, you can do that. There's also another word, it has the word multiply in it as well that some people use to remember how to do this. But multiplying each side by 4 would be the fastest way. Yep. That's only when you're adding or subtracting. So you're not going to have to worry about any common denominators there. But the other word with multiply, it's 2 words, something multiply. Yep.
Cross multiply?
Yeah, some people remember it as cross multiply. 3 times x equals 2 times 4, and then divide each side by 3. Right. That's basically the steps you're going to have to do with every law of science problem this week. Okay, cross multiply. Okay, sometimes we can do it a little quicker, and if we can, I might bring that up. But in general, a lot of cross multiply. All right, so first thing we'll do is we're going to make a sketch, because remember, law of sines can only be used for these three problem types. If you make a sketch, it's going to be easy to determine if it's one of those three types. Okay. You can also do it without a sketch, and maybe I'll show you how to do that too. We're gonna definitely make a sketch for the first few. Once we make a sketch, then we're going to put all our data in a table. Okay. The way the table's going to look, when we get to this one, we'll have three sides and we'll have three angles, and I'll put boxes around everything we got to figure out. So it's just like we did 2 weeks ago, two academic weeks ago. The only difference is now that box doesn't always have a 90 in it. All right, so we got that. Remember, Pythagorean theorem does not work because we don't have right triangles. I mean, if you did have a problem this week that had a 90 in it, I wouldn't count on that. But if you do, then you could use Pythagorean theorem. But one thing that does remain the same is all the angles in a triangle have to add up to how much? They still have to add up to 180. So that fact we can still use. All right, so we're going to try to do 3 questions. We'll do one of each type. Law of science problems do take a minute because there's 3 things you got to solve for. So it's actually like doing 3 different questions. So they take a little bit of time. All right, so they give us 3 pieces of information. Alpha is 40. Beta is 60, and A is 4. All right, so first thing we'll do, let's make a sketch. Again, it's not to scale, it's just basically to tell us what's across from what. That's all it's for. All right, so we've got A, and we need to put that across from alpha. We've got B, and that needs to go across from beta. So B 60, C, and gamma. All right. So 3 pieces of information that we have are right there. What kind of triangle is that? Describing it using 3 letters, like A's and S's. Yeah?
S-A? Or no, S-A.
So not SAS. If it was SAS, we'd have to use law of cosines to do it.
ASA.
ASA. I agree it is 2 angles and a side. Yep.
SAA.
SAA. Yeah. So it's 2 angles and a side, but the side that you know is not the one connecting them. Okay, that would be side C. For this to be ASA, you'd have to know side C. Okay, so it's not ASA. And you can say either angle, angle, side, or you can say side, angle, angle. But the point is you have 2 angles and a side that does not connect them. Okay, so any questions why it's that tight? All right, so now if we go and look at our chart, we know that that type, wherever our chart was, that type falls under one of those 3. So this is a law of science problem. Okay, the other way that we can tell this is going to be law of science is when you look at your table, if you have a full row, a complete row, that means it's law of science. Doesn't mean you have to be given a full row. It just means you either are given a full row like you are here, or you can find a full row somehow. Okay. Most of the time, that finding a full row somehow would involve the fact all the angles have to add up to 180. Okay. But we're given a full row, so this is definitely law of science. We can find any one of the 3 things we don't know. Actually, there's only 2 things we could pick from. So we can't pick C, but you could either do B or you could do gamma first. Either one. So which one do we want to do first? Yeah?
Gamma.
Okay, so we can do gamma. That one's pretty straightforward because we have 2 out of 3 angles. If we're going to find gamma, what would that come out to?
7,
All right, and how did you figure that out?
or is it 8? What is it, add them together and subtract from 180?
Yeah, you just have to add them all up and then subtract from 180. What are the 2 that we have add up to?
100.
100, and if you subtract that from 180,
80.
80. Yeah, so that's going to be our third angle. Okay, so one piece of information is done. Any question on how we got 80? Now, when we solve right triangle problems, what did I say about using a piece of information that you found yourself? Yeah.
Don't do it.
Yeah, why did we say not to? Why is it a bad idea to use something you found? Yeah?
It could be wrong.
It could be wrong. And what else can happen? It didn't happen in this one, but it does happen a lot of times with the sides. What kind of answers do we get? Yeah?
Decimals.
Yeah, we get decimals. So there's a couple reasons why when we did right triangles, we did not want to use what we solved for to find other things. Well, this week, you cannot avoid that. There's no way to get C without using gamma. Okay, you have to. So what that means is if you get gamma wrong, then C is going to be wrong. All right. We could still get B right. Okay, B has nothing to do with gamma. Those are separate. All right. But information in the same row is going to rely on each other. So C relies on using gamma. All right, let's do B first. Okay, so define B. Well, the first thing you do is you look at your table and you pick out the full row. In our case, the full row has an A and it has an alpha. So if you go back and look at your formula, you are definitely going to start with this part of the formula, sine of alpha over A. And we're going to fill that in. And since we're solving for B, we're going to use the second part, sine of beta over B. So for this part of the problem, we are not using the third fraction. Doesn't mean we won't come back to it, but for now, we're not. So sine of alpha over A equals sine beta over B. And fill that all in with these numbers. Sine of alpha is 40 divided by A, that's 4. So sine of alpha over A equals sine beta over B. Okay, so beta, we've got that as 60. And B, we don't know. So that's how you set up your equation. All right, now, what did we say to solve that? How do we solve it? Yep. Cross multiply. Okay, so you've got 4 sine 60 equals, and then you're going to do B times the sine of 40. So that's your first step. You multiply the diagonals and you set them equal to each other. All right, so now we got that. And our last step is to get B by itself. So how would we put the sine 40 on the left side? Yep, we're going to divide. And what are we going to divide by? Sine 40. So now when you divide that, don't try to cancel anything here, like you say, oh, 60 and 40 are both divisible by 20. No, don't do anything like that. Just type that in exactly the way you see it. Okay, so that's our answer. And we're going to round to 3. Okay, 3 decimals. Okay, For this week, I know last week we did I think we did everything in radians, all the graphing. This week it's going to be degrees. Okay, so once you set it in degrees, keep your calculator in that mode all week. But remember, other people use your calculator, so they may change it for what they're doing, so just put it back in degrees when you use it. All right, so 4 sine 60 divided by sine 40. All right, and that gives us 5.389. That's how you get B. All right, so now we've got 2 sides. Could I use Pythagorean theorem to get C? Joe, what are you thinking?
No,
How come?
it's not a right triangle.
It's not a right triangle, right? That's an 80-degree angle. So because we don't have a right triangle, don't use Pythagorean theorem. Okay, we're going to find C same way we found B. So every law of sines problem pretty much starts out like this. So I usually write that down first because I know that's the template. Now, to use law of sines, you have to pick a full row in your table. How many full rows do we have now? 2. So you could pick the first row or the second row. But which row do you think is better to pick? Right, how come?
There's no decimals.
Right. Everything was given, there's no decimals, so we're going to start with sine of 40 over 4. But this time, we're solving for C. So we are not using the part of law of sines that has a B in it. We're using that because it was given. And we're using that because we want to find C. So that's what you're going to set up this time. Sine of alpha over A equals sine gamma over C. Okay, gamma, again, we solved for that. I know we don't like to use things we solve for, you have to. That's how that works. So sine of 80 over C. Okay, now when I cross multiply, I generally do it all in one step. I don't do the step in the middle. So what's going to end up happening is it's going to be 4 sine 80, and then you're going to have to divide by sine 40. That's going to be the end result if you cross multiply. If you don't want to do it all at once, you don't have to. You can do it out 2 separate steps, but that just saves us a little time. So it's always the product of the 2 that are just numbers divided by the one that's on the diagonal with the letter. That's the pattern. And now what we typed in on the calculator to find B and what we're going to type in to find C, they're very similar. So what I usually do to save myself time is I press second and I press enter. And that'll bring up the last thing that I just typed. All I have to do is change the top to 80 instead of 60. That's the only thing that's changing in my calculation. One number. Okay, if you don't want to do it that way, that's fine. You can type it all in again, but just saves you a little time. And that gives me 6.128. Now, a couple quick things you can check, just to make sure there's not something really wrong with it. The biggest side should always be in the row with the biggest angle. Yep. Smallest side should be with the smallest angle. That looks good. And any 2 sides added together need to be bigger than the third. If that didn't happen, then you did something wrong. Because this kind of problem always has a solution. So it's never going to be a problem where it's not possible to do it. And you can always solve these kind of problems. Are there other kinds of problems you cannot solve? Yes. But it's never one of these. Okay. Any questions on how we got those three pieces of information? All right, so that's the angle side. All right, let's look at this one. All right, so like we did last time, I'm using three letters. First, I just want to know what kind of triangle is this one. So using three letters. It might be a cube, we don't know yet, we haven't found that third angle, but I wouldn't count on it being a cube. But yeah, just using three letters.
Angle, side angle.
This is angle, side, angle. Well, what's the difference between this and the last one? Yes, two angles and a side. The difference is the placement of the side. This time it's connecting the two angles. Last time it was not. Okay. All right. Is angle, side, angle one of the three types that we use law of sines for? Yeah, it is one of the three types. So law of sines, definitely we're using that. Okay, now for law of sines, you are supposed to have a full row. Do we have a full row that was given? No, there is no full row that was given to me. Okay, do I have a full row that I can figure out? Yes. How can I get this last angle? Yeah, what do you get if we add 45 and 40? 85, and then subtract that from 180? 95. Now, we have a full row. So what's the difference? Well, in terms of solving it now, it's not that big of a difference from the last problem. But this piece of information is very important. When you are using law of sines, you need to use the full row to do everything. The problem is you were not given this full row. You calculated that number. So that means if you get this number wrong, then what's going to happen? The whole problem is wrong. Okay. So this problem has, it's all kind of interconnected, where if you get one thing wrong, you'll get them all. So just be very sure that you've added these up, subtract from 180, and you get 95. Okay. So double check. Now, once you have that, A or B, doesn't matter which one you do first. Let's do A first. Okay, so remember the template, how it's going to look. Sine of something. Sine of something on that side. And now what could I fill in on the left side from my table?
Sine 95.
Yep, we can do sine 95 over 4 equals. And now, if you would put that on the right side, that's fine too. You're just going to have sine of 95 over 4 in one of the fractions. Now, what's going to go on the right side if I'm finding A? Yep. Eliana.
Sine 45 over A.
Sine, what is it?
45.
Yeah, so yeah, sine 45 over A. Okay. And now when I write my final answer, can someone tell me it's going to be what times what divided by what? Yeah.
4 sine 45 over sine 95.
Yep, perfect. So there's your formula to find A. 4 sine 45 over sine 95. Okay, so let's put that in. 4 sine 45, sine 95. Okay. So we've got 2.839. Now make sure you don't put a degree symbol on that, because that's not an angle, that's a side. Okay, if you accidentally label your sides with degree symbols, you're going to lose some points because it's not an angle. Same thing if you forget the degree symbol. Well, if you don't put a degree symbol on that, that's 95 radians. That's a big difference. So make sure if you need a degree symbol, you put it. All right, now let's find B. Okay, so sine. There you go. And to find B, we're going to start out the same way we found A. Always go back to the row that was given. So sine 95 over 4. Now, can someone else tell me, if we're finding B, what's going to go on the right side? Yep.
Sine 40 over B.
Sine 40 over B. Okay, and I know when we do law of sines, we're not really thinking about it, but you're really taking a triangle here, you're drawing in, and you're finding this height, and you're using that to solve the problem as a right triangle. This law builds all that into it for us. Okay, so now let's cross multiply. And can someone else tell me what's going to go in that box when I cross multiply? Christian?
4 sine 40 over sine 95.
Yep. 4 sine 40 over sine 95. Okay, so all I have to do from the problem I did on the left is change the top number from 45 to 40. Everything else is the same. Okay, so that gives me 2.581 if we're rounding to 3 decimal places. Okay, looks like A and B are pretty close. And that's because alpha and beta are pretty close. Alpha is a little bit bigger than beta, so A should be a little bit bigger than B. Okay, and C is the biggest side, and that is with the biggest angle. So everything looks okay. All right, any questions on that one? So whether it's angle, side angle, or angle, angle, side, they're both pretty similar. Okay, there's not really a lot different when you go to solve. Okay, so the last case is side-side angle. This one is different, okay, and this is what we'll spend. This will be our last example. We'll do this one today, and we're going to spend some time tomorrow with this again as well. Okay, so first thing is, how do you know it's side-side angle? Well, if you draw a picture, that's A, that's B, that's beta, and that's alpha. You have a side, another side, and an angle that is not between the two sides. If I had given you gamma, well, I have not taught you how to solve that yet. If you've done law of cosines, then yeah, you would know how to do it. But if not, then the law that I taught you today would not work. Okay, but I didn't give you gamma, I gave you alpha. So this is side angle. All right, so now what can happen with side angle? Well, it could end up being a regular problem. And when we solve for what we don't know, which is the C, the beta, and the gamma, so when we solve for the three things that are underlined, we just get one solution, like the last two problems. Or, when we try to solve for the three things that are underlined, we end up with two different numbers for each of the things that are underlined. So you get two answers here, two answers here, two answers here, for a total of 6 answers. Or we could try to solve this problem, and something happens when we do it, and we realize that there is no solution. That means that the information they gave us, it is impossible to make a triangle out of. Okay, so with side-side angle, the way I remember that this is the tricky one is that this case is a real pain in that, all right? So if you write it backwards, that's how I remember, it's a pain, right? So you gotta remember to check for, does this have two solutions? We have to check for a no solution or one solution. Okay, one solution is the kind of problem we've been doing so far. And side-side angle is the only type that these three cases can ever happen. Okay? There is one other type we won't talk about until Wednesday that could have a no solution. But as far as the two solution, it's only side-side angle. Okay? Don't have to worry about two solutions in any other problem we do all week. All right, so let's put all that in the table and see what we've got. So by looking at the table, how can you tell that that's law of sines? We have, what about one row? It's complete, yes. You have one row that's complete. You also have one row that's completely empty. Now, we had that in the last problem too. This last row was completely empty when we filled in what they gave us. But the difference was you were able to find something in that last row using the other two. In this one, there is no possible way to find anything in that last row right now. You can't. You say, what about Pythagorean theorem? Well, then you're assuming gamma is 90. We don't know that. So you can't use Pythagorean theorem to get C. You can't add two angles together to get the third one, because you don't know two angles. This last row is useless, right? So that means when you start to solve it, that is the first thing you need to focus on. Okay, so if you have a row that's completely empty and there is no way to find anything in it right away, that's how we can tell it's side-side angle. Okay. Now, once you get beta, then you'll know two angles. You can add them up from 180 to get the third angle. That'll be the second thing we do. Then, once you finally get a piece of information in the bottom row, you can get the bottom side. So that's going to be the order we do this problem in. 1, 2, 3. No, there's no other choices. Okay, so let's set it up to find beta first. So what can I put on the left-hand side to get this going to find beta? Leon?
Sine 40 over 3.
Yeah, so far that's the same. So let's do sine 40 over 3. And what are we going to put on the right-hand side? Yep.
Sine beta over 2.
Sine beta over 2. Now, before we go any further, can someone tell me what is different about that? That's very different than all the other ones we've done so far. Yeah?
We have the bottom on the right. No,
Can you say that again?
we have the side on the right, not
Right, we have the side on the right side. What don't we have?
the angle.
We don't have the angle. This time the angle that we are using is inside of a trig function. And that's what we're solving for. Now, this is the one where you don't need to cross multiply because it actually is going to result in an extra step. Okay. Our goal for now is just to get sine beta alone. If I cross multiply, I'm going to put a 3 with it. I'd have 3 sine beta. So I just want to put this 2 on the left side. How would you move the 2?
Multiply by 2.
Do what? Yeah, multiply by 2. So that's all I'm going to do at this step. Times 2. So that's 2 sine 40 divided by 3 equals sine beta. Now, this is something we did, or something we used when we did right triangles 2 weeks ago. I need to get rid of sine now. How do you get rid of sine in an equation?
Cosine.
So sine and cosine are co-functions, but they don't cancel each other out. Yeah?
A negative. A negative function. A negative. I forgot how to do it to my camera. I don't really know.
So kind of something with a negative, but that's we can't just put a negative in front of it.
It's called inverse.
Inverse
Sine.
sine. Yeah, we have to take the inverse sine of both sides. So you're going to type all of that in on the left. And what happens when you take the inverse sine of what's on the right?
Sine cancel.
The inverse sine and the regular sine cancel. What's left on the right?
Beta.
Beta. And that's exactly what we want. So now we need to type that in. Don't try to cancel anything on the left. Just type the whole thing in just the way you see it. So we got second inverse sine. It is important you close your parenthesis for the 40. If you don't close the parenthesis after the 0 and the 40, it's basically going to think you want to do this. You don't want to do the sine of 40 divided by 3. You want the divided by 3 to be in the bottom, totally separate from that. So just like that. All right, now one of two things is going to happen when we type that in. We're either going to get an error, which would mean this is no solution, or we're not, which means there's at least one solution. All right, well, there is at least one solution. So we're going to write that down, 25.374. Okay, and what I generally do is I put it up in the box a little bit higher. In case there's a second solution, I'll put that underneath it. First, any question on how we got 25.374? I just put the answer up in the table. All right, so now, once you have that, you use that to get your second answer. Yeah?
My calculator is giving me a domain error.
So it's probably something with parentheses, or you're not in degrees.
I'm in degrees.
You're in degrees, okay. And you typed it in exactly like that?
Oh.
Good, yeah.
So why is the parenthesis on the outside of the 3?
So that's closing the parenthesis for the inverse sine. So that's putting everything in the inverse sine, because I want to take the inverse sine of all of it.
Okay.
Yeah. Yeah. All right, so now to check for the second answer. You're going to take the first answer that you just got. It could be alpha, it could be beta, it could be gamma. It depends on the problem. Okay, but for us, it was beta. But the point is, take whatever answer you just got and subtract it from 180. So let's do that. So 180. Oops. 180 minus, and since I still have the last answer on the screen, I can just press second and press the negative sign. Bless you. So if there's another answer, that's what it is, 154.626. Now, I'm not going to write that down as an answer. I'll put it off to the side as like a question mark. Because I don't know if it works yet. Or a better way to say it is, I don't know if it fits yet. So to get the second answer, to get the possible second answer, subtract what you just got from 180. But then you have to see, does that answer that you just got and the one that they gave you fit in the same triangle? Okay, so I got 154.626. They gave me which angle to start this problem? They gave me a 40. Can you fit 154 and 40 in the same triangle? No. That would add up to more than 180. So in our case, we don't have to write it down, but that's the reasoning. Right? So if there's another answer, it's the 154.626, but with a 40 to start with, if you add them up, that's 194.626. That's more than 180. So it's not going to fit in this triangle. So what that means is we can cross out the 154, we can ignore it, we don't need it, it doesn't work. So is there any question on how we got the 154 or how we determined it doesn't work? Okay. So now, because it doesn't work, we can finish this problem just like a regular problem. That was the only thing that was special to this one, and it didn't even apply because it didn't work. All right. Now, we've got alpha and we've got beta. How can I get gamma? Yep, so if I add those up, 40 and 25 gives me 65. So do 180 minus 65, 374. And that gives me 114.626. Now the bottom row is a partial row. Okay, I can work with a partial row. I couldn't work with it before because it was an empty row. Now it's not. So now we can find C. Let's just do that over here. Okay, so sine. Okay, how many full rows do I have now? 2. Row A and row B. Which row should we use to find C? Yeah, because it was given, there's no decimals. So it's the same way we started out when we found beta. So sine 40 over 3. And what's going to go on the right side? Yep, so we're going to do sine 114.626 over C. Okay, cross multiply, and you will have your answer for C. All right, so we got 3 sine 114.626 divided by sine 40. And that gives us for C 4.243. 4.243. And that's the side-side angle case. Okay. Any questions on that? Okay. Or anything here that anyone still needs to copy down? All right. So that wraps up what we're going to do today with law of sines. Tomorrow we'll do a little bit more with side-side angle. We'll go over the homework, and then we'll that'll wrap up law of sines tomorrow. So remember, tomorrow we don't have class until afternoon, and then Wednesday we don't have class, so we'll be doing law of cosines on Thursday. That is the homework for tonight. It's 9 to 13, 17 to 21, and 25. And that's all odds.